This next section wants us to determine what elements are denoted by the following electron configurations. So whenever we're trying to figure out what element it is, we have two options. We can either add up all of the exponents to get the total number of electrons. So I'm going to do two examples like that, and then I'll show you the other way that we could do it. Okay, so remember our exponents are these tiny numbers in the top right. So if I add these up, 2 plus 2 plus 6 plus 2 plus 4 gives us, it's 4, 10, 16. So this tells me I have 16 total electrons. And I know in my elements, my electrons have to be equal to my number of protons. My number of protons is shown by the atomic number. So if I have 16 electrons, all I need to do is look for 16 on the periodic table, and that's what element it is. Okay, so my element for number 11 is sulfur. Okay, I'm going to do number 12 like that as well. So I've got 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 and plus 1 is going to give me, this is 10, this is 20, 30, 36, 37. So all I have to do is find number 37 on the periodic table, which is right here. This is rubidium. Okay. Rubidium. All right. Another option I have is to look in the last one that's noted on here. So I can look in the 5p energy level and then count the third one. Okay, and that should show me what element it is. Okay, so here is my 5p. Let me scoot this up a little. Here's my 5p energy level. So we're in the p block, and remember p starts at 2, so this is 2p, 3p, 4p, and 5p. And if I count 1, 2, 3, then I will get my element. So this is antimony. So that's my answer for this one. Okay, we'll do 14 the same way. All right, so I made a little mistake here on number 14. When I was trying to identify the element, I was a little bit confused if I should count. Well, let me just explain. So we started with xenon, and then we went to 6s2, and then 4f14, and then 5d6. So initially I thought, we would start here at the first element in the 5d and count 1, 2, 3, 4, 5, 6 and get iridium as our answer. But then when I looked at it, I was like, I'm not sure, because there's not really an element here. So I thought maybe it could have been 1, 2, 3, 4, we count this as 1, and then 2, 3, 4, 5, 6. Maybe it's osmium. So I wasn't sure which one to pick, but then I realized I can just count up the valence electrons. If you're thinking, how am I going to do that if it's abbreviated? Here's what you do. So xenon has 54 electrons. Okay, so 54 total electrons. And I can just add up the rest of these, the exponents I mean. So 2, this is 14, and 6, when I add those up, this is 60, I get 76 total electrons. And the element that has 76 total electrons is osmium, not iridium. So this answer right here should actually be, how do I spell it? Osmium? O-S? Yeah, osmium. Okay, so I made a boo-boo on this one, but I figured out how to fix it, so I thought I'd share it with you. So number 15 is in 5F. So I'm going to look down here in my F block. F starts at 4, so this first row is 4, second row is 5, and it stopped at 11. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I have Einsteinium. So this one is obviously named after Albert Einstein. So Einsteinium. Okay.